If there's one thing that a lot of developers, a lot of Java developers, and really many programming language developers struggle with, is the concept of what's called aliasing. So consider declaring an array of integers a. So we declare it as an array of integers a, then we instantiate it to be an array of, or a new array of integers of 5 elements. Okay, so remember what this means. This means that A now references an array in the heap of 5 elements. Okay? But let's say we want to declare another array that is also of 5 elements. Well, one thing someone might think is that we can just say, or rather, let's say that we want B to be a copy of A, right? We want B to be a separate array that's just a copy of the values in A. So let's say in between here, we set the values of the array to be different things. Like let's say instead of all zeros, they are just like, I don't know, let's say 1, 2, 6, 24, 120. Okay? Now, if you do this assignment here, where we assign A to B, you may think, well, then that means that here, B now points to a separate location in memory, like this, right? Because it's a copy. Well, unfortunately, that's not what's happened. Java is doing something called, or rather, what you've done is you've created something that's called an alias for A. So, B is an alias for A. That just means that B is another name for A. So if you think of what alias really means, like alias just means that it's another name for something. So what this means is that B actually doesn't point to anything in memory, it points to A. So let's say we do B at 3. That's going to say, well, we're going to look at B, and we're going to see what it points to. B points to A, right? And now A points to this thing. So B at 3 is we go through A, and then we go to what it points to, and that's this value. So this resolves to 24. This is the same thing if we were to do A of 3. Okay? So A of 3 resolves to 24 because we just follow the link from A into the array, and then we get 24. Okay? But the big thing about this, the thing that really can screw people up, is what it really means to be an alias for something. So, because we have these links here, if we change either A or B, then it will change what the value, like, so let's just show this with an example. So, let's say we do A of 2 is equal to 100. That, of course, is going to then change this element to be 100, right? Because we go to what A is pointing to, we say its second element is now 100. But what do we think B at 2 is now going to be? Well, this should not surprise you because we're just saying B at 2 follows to what A is, and now A points to some array where the second element is 100. Because remember, like I said, B is just an alias for A. That's all it is. It's just a copy, or rather, it's not a copy. I should really be careful about how I phrase this. But B just references whatever A references. Okay? Now, it's important to think about the implications of this. So, if you accidentally, or if you on purpose, change one of these arrays, like if you change B at 1 to be 5,000, then that means we're going to look through what B points to, and it points to A, and now this becomes 5,000. Okay? So now if we do A at 1, this is also going to be 5,000. So this aliasing stuff really becomes a problem or not a problem, it just becomes something that we absolutely can't ignore when we start talking about objects. But this is absolutely something that you need to be aware of, and that's why I'm spending time talking about it. Okay? But what happens if we reassign A? So for example, let's say we do some more stuff, and then we say A is equal to new int of, let's say, just 10. This means that A is now going to point to something else. Okay, so A is going to point to something. So I know this has, so let's just draw more lines to make it show that there are more elements in it. A is now going to point to this. Now you may think, well, does that mean that B now points to this underlying array? The answer is no. So it's a little disingenuous to draw an arrow from B to A, because that's really just for demonstration purposes. B actually just points to whatever A was pointing to. So really having it point to A and then to the underlying array, that's a little disingenuous because that's not correct. Because if we change what A points to, B is still going to point to that thing. Okay, so B at 1 is still 5,000. Okay, but A at 1 is 0, because we just remember that we said that all of the elements of an array are of an integer array are initialized to 0. So 9, 10, there we go. So A at 1 is of course going to be 0. But B at 1, it still points to that array that A used to point to, and it's now 5,000. Now what happens if we do B is equal to new int? B equals new int of, let's say, 20. That means that B is now going to point to some array that has 20 slots. I'm not going to draw them all. So B is now no longer going to point to this thing. It's going to point, let's fix the line from A to this. A is now going to point to this. So, if there are no other references to this array, Java is going to what's called garbage collect this array. Because remember that arrays take up space in memory, right? They're not free. So, if there's no possible way to get to this array, then there's no need to have it in memory. So Java will say that that array is, I'll write this down, unreachable, and therefore it gets garbage collected by Java. Okay? So if you ever lose reference to an array, or to any object, not just an array, then it will become garbage collected. Okay? And that fact is really important to know, because if you accidentally reassign variables in a way that you don't know what you're doing, then this could end up happening, and then you lose some data that you thought you might have still had access to. Okay? So this idea extends into any object. So we talked about this very briefly with strings. I didn't mention the term unreachable or garbage collector, but I think now is a great place to really talk about it, because again, this extends to any object, any reference type. So when we start talking about other things in the when we start talking about other data structures in Java, then this idea still applies. This aliasing idea, the garbage collection idea, all of that continues to remain the same. So it's important to really understand what's going on now with arrays when they're simple, so you can generalize that idea later on.